start chatting about this. However far you got was exactly how far you were meant to go. Who's got a nice first step for solving for little a?
I guess with a, I guess the cosine big A, which is equals 5/19. And from that, I got the angle value.
So you started by solving for big A first, right? This angle here. And you're saying you can use the two sides given, connecting them with cosine. So cosine of big A will equal, what is the definition of cosine?
Adjacent over hypotenuse.
Cool. So it's this adjacent length divided by the hypotenuse length, which in this case, which side is adjacent to A? Does somebody have a next step for how I can get A by itself?
Cos inverse.
Cosine inverse, cool. So I'll do that on both sides. And what value did you get for that, Musnil?
I get 74.74.
Cool. That sounds right to me. Okay, that's big A.
Now that we have the value for big A, we can just work out the value of big B, which should be pretty easy since all the internal angles in the triangle add up to 180. We can just subtract 180 from whichever we know. It's gonna be 180 minus 90 plus 74.44, which should give us about 15.26.
That's the second unknown. Very nice. And we're gonna use this in the project today. Today we are doing a project. We're gonna design our dream bridge, the most convenient bridge that would connect either your home or your bed or your community to some other place that you like to go, and then either a third stop so that we can have a triangular bridge, or you can have a different route back from the first stop. Any kind of bridge that has three sides, just like a triangle, and then we'll apply what we've been doing with the law of sines and law of cosines to design the bridge and get all the different dimensions. Quick reminder about why we use the law of sines and law of cosines. When we have non-right triangles, we need new techniques to start solving for missing sides and angles. So that's why we have the law of sines, the law of cosines. And the first step today is just really having clarity on what you want to build a bridge for, where you want to start and where you want to go, so that it'll have three sides. And then you can start trying to get those measurements. Nope, it does not have to be realistic. You can go to Pluto and then Jupiter and then come back. Whatever you would find most convenient. What's your unrealistic bridge you want to build, Vanessa?
So from my house, like it's up in the mountains, but yeah, from my house to the beach so I can go running, and then from the beach, and then and then to my best friend's house.
Beautiful. How about you, Katie Grace?
Well, I was gonna do it to my best friend's house and then like to the center of Bath where I also have work, and then back to my house. But I've now seen it on the map and it just would not work. Yeah, it doesn't really work in the sense it's not really even a triangle because it's like all over the place.
Yeah, I think it's nice when the triangle kind of like there's similar distances for each side. How about you, Olive?
So I was thinking of having two bridges between my theatre that I go to and my climbing gym.
I made mine from my bedroom to the Taj Mahal to the Great Wall of China and back to my bedroom.
Okay, sweet. No, that sounds like a perfect bridge. And do you have three measurements, like the distances between all three of those spots?
Yes, yeah, I do.
So these three places I have selected. One is my home, one is my gym, and one is my cousin's home. On the maps, all these places are 180 degrees because the road is flat.
So what I might do is like, let's say the bridge is 2 stories high or 10 stories high. So it goes over all the buildings or something like that. Then all three of those sides will come together and form a triangle. So like once you have the idea of where you want to go, you want to get 3 measurements that give you some information to work with, and then you'll calculate for the other 3 measurements using law of sines, law of cosines.
So I have selected 3 places for my bridge. One is my home, one is my cousin's home, and one is my gym. So in this way, I have calculated the 3 dimensions. So I digitally point out the angles like A, B, C, and write out the side lengths: 3 kilometer, 5 kilometer, and 8 kilometer.
Very cool. This is beautiful. I think a lot of learners were proposing something like this where you measure the 3 side lengths. What's going to be your first step here to get in a missing angle?
I will use the law of sines and law of cosines to find the missing angles.
We use the law of sines or the law of cosines to get our first angle. Yeah, we only have the lengths. Bingo. If we had one angle measure given, then we'd be able to create a complete fraction and then solve for another missing angle. But before we have at least one angle, we have to use the law of cosines. And I'll see you all same time, same place next week. Have a good week.